Hello everyone. Let me continue with the Ionic equilibrium part. Okay. Today I am going to describe concept of acids and bases. Okay. So let me go through concepts of acids and bases. Now, see, the given substance is said to be an acid. The given substance is said to be an acid if it has the following characteristics. If it has the following characteristics. Right. So the given substance is said to be an acid if it has the following characteristics. Now, what are the characteristics of an acid? See, the first point, it is sour to taste. The first and important, acids are sour to taste. Second, certain salts are soluble in acids. Certain salts are soluble in acids like carbonates, bicarbonates, etc. Example, carbonates and bicarbonates of group 1 and group 2 elements. See, certain salts are soluble in acids like carbonates and bicarbonates are the best examples. The two carbonates and bicarbonates are group 1 and group 2. The third point, reacts with high electropositive metals and liberates hydrogen gas. See, reacts with high electropositive metals and liberates hydrogen gas. And the fourth point, converts blue litmus to red. Acids can convert blue litmus to red litmus. The fifth and important point, when acid reacts with base, it gives salt and water. We call it as neutralization. So these are the basic characteristics of an acid. If the given substance has these following characteristics, it is considered to be an acid. Okay. Similarly, base has the following characteristics. So basic characteristics of a base, let me go through. Okay. See, if the given substance is said to be a base, if it has the following characteristics. The given substance is said to be a base if it has the following characteristics. Okay. This is my first one. Bitter to taste. A base is said to be bitter to taste. Next, soapy or waxy to touch. Soapy or waxy to touch. Next, converts red litmus to blue litmus. Converts red litmus to blue. The fourth point, when base reacts with acid, as usual, neutralization gives a salt and water. Okay, these are some basic characteristics of a base. A given substance is said to be base if it has the following characteristic properties. Okay. Now, and one more important point, to understand nature and properties. To understand nature and properties of acids and bases, we have to follow three important theories. Right? So to understand nature and properties of acids and bases, we have to follow three important theories. Okay, what are the three important theories? Let me go through one by one. Okay, So the three important theories are Arrhenius theory, Bronsted and Lowry theory, and Lewis theory. So we have to follow three theories to understand the nature and properties of acids and bases. So Arrhenius theory, second Bronsted and Lowry theory, and the third one is the third and important one is Lewis theory. Okay, so these are the three important theories we can understand about the nature and properties of acids and bases. So let me go through first Arrhenius theory. Okay, according to Arrhenius theory, what is an acid or what is a base? First, what is an acid? According to Arrhenius theory, acid क्या होता है? See, the substance which increases H plus ion concentration in aqueous solutions. The substance which increases H plus ion concentration in aqueous solutions is called as an acid. Okay. The substance which increases H plus ion concentration in aqueous solutions is called as an acid. Example: HCl, HBr, HNO3, H2SO4, CH3COOH, H2CO3, carbonic acid, etc. And what is base? Base can be defined like this. See, the substance which increases OH minus ion concentration in aqueous solutions is called as a base. Okay. So for example, like NaOH, KOH, MCOH twice, okay, NH4OH, etc. So these are some acids and some bases. So based on Arrhenius theory, substance which increases H plus ion concentration in aqueous solutions is called as an acid, and substance which increases OH minus ion concentration in aqueous solution is called as a base. Okay. Now, what is neutralization according to Arrhenius theory? As per Arrhenius theory, what is neutralization? According to Arrhenius theory, acid reacts with the base and gives rise to salt and water. As per Arrhenius theory, acid reacts with base and it gives salt and water. Okay. For example, HCl plus NaOH gives rise to NaCl plus H2. Okay. It is an exothermic reaction, right? The acid-base neutralization is an exothermic reaction, and it is considered to be irreversible reaction. As per Arrhenius theory, acid-base neutralization is an exothermic reaction, and it is considered to be irreversible. Okay. Now, one more important point, based on extent of dissociation, acids are classified further into two types. Based on extent of dissociation, acids are further classified into two types. Okay, this is the first one, strong acid. See, what is strong acid? Which ionizes almost 100%. So which ionizes almost 100% in aqueous state or aqueous solution is called as a strong acid. which ionizes almost 100% in aqueous solution is called as strong acid. Okay. Example: H2SO4, HI, HNO3, and H2SO4, etc. Next, what is weak acid? So, which ionizes to a very less extent in aqueous solution. Which ionizes to a very less extent in aqueous solutions is called as a weak acid. Okay. For example, weak acids के लिए, for example, acetic acid, CH3COOH, carbonic acid H2CO4, and oxalic acid H2C2O4, etc. So, strong acids and weak acids as per extent of dissociation. Okay. Similarly, bases are also two types, like a strong bases and weak bases. Okay. So let's also let me go through it. Based on extent of dissociation, bases are also classified into two types. Based on extent of dissociation, bases are classified into two types. Okay. So based on extent of dissociation, bases are classified into two types. This is my first one, strong base. Okay, first let me go through strong base. As usual, what is it? Which ionizes almost 100% in aqueous solutions. See, which ionizes almost 100% in aqueous solution is called as a strong base. Which ionizes almost 100% in aqueous solutions is called as strong base. Example: NaOH, KOH, RbOH, and CSOH, cesium hydroxide, etc. Next, similarly, weak base. Here we can say which dissociates to a less extent, in aqueous solution is called as a weak base. Example: NH4OH, ammonium hydroxide, CaOH twice, calcium hydroxide, FeOH twice, and FeOH thrice, etc. Okay. So, based on extent of dissociation, we can separate strong bases and weak bases like this. Okay. Now, let me go through some more details. Listen carefully. Let me find some dissociation constants of these weak acids and weak bases. Okay. Now, continuation from this. Assume a weak base. Assume a weak acid HE. Okay. In its aqueous state, it has the following equilibrium. Right. Assume a weak acid in its aqueous state. Okay. It has the following equilibrium. So HCl plus H2O, right? Otherwise, you better to go to like this. HCl gives rise to H plus aqueous plus A minus aqueous. In aqueous state, I have taken HA aqueous gives rise to HA plus A minus. Now let me go through initial concentration initial concentration. Let me take this one C moles per liter, this one 0, 0. Now at equilibrium, if its concentration is alpha, C alpha, C alpha. One mole लेने से alpha alpha. If you take C moles, it becomes C alpha, C alpha. And this one, undissociated acid, C into 1 minus alpha. Therefore, dissociation constant of acid, Ka equal to C alpha into C alpha by C into 1 minus alpha. C get cancelled. So Ka is equal to C alpha square by 1 minus alpha. Okay, and one more point here. For a weak acid, alpha is very less when compared to 1. For a weak acid, alpha is very less than 1. Therefore, alpha is neglected. Alpha is neglected in denominator. Therefore, alpha is neglected in denominator. Okay. So therefore, Ka is equal to C alpha square, and alpha square is equal to Ka by C, and alpha equal to root Ka by C. Okay. So the degree of dissociation of a weak acid can be written as alpha equal to root Ka by C, where Ka is dissociation constant of weak acid. Okay. Dissociation constant of weak acid. Next, since H plus ion concentration is equal to C alpha, therefore H plus ion concentration is equal to C into root Ka by C. Therefore, H plus ion concentration can be written as root Ka into C. H plus ion concentration is equal to root Ka into C. pH is equal to cap minus log H plus ion concentration. Therefore, pH is equal to minus log root KaC. Right? That can be written as minus half log Ka minus half log C. Okay. Minus half log Ka minus half log C. Okay, wait a minute, it's not visible properly. So pH is equal to minus log K. So I'm writing from here. Okay. So therefore pH is equal to minus of half log K minus half log C. Then pH is equal to, if you separate half, minus log Ka minus log C. Since minus log Ka can be written as pKa, therefore pH is equal to half into pKa minus log C. So the pH of a weak acid can be represented like this. pH is equal to half into pKa minus log C. Okay. Now, let me go through some important aspects here. Okay. Higher the value of Ka, higher will be acidic strength. Higher will be acidic strength. Okay. Higher the value of Ka, higher will be the acidic strength. Next, less will be pKa, more will be, क्योंकि negative logarithm to the base 10 of Ka, no? Minus log to the base 10 of Ka is pKa. So therefore less will be pKa, more will be acidic strength. Right? Higher the value of Ka, higher will be the acidic strength. Less will be the pKa, more will be the acidic strength. Understand? Next, one more. Less will be the pH. Less will be the pH. More will be the acidic strength. SN3. Okay, so this is about a weak acid according to Archimedes theory. Okay, so similarly, let me go for base also. A weak base भी आप ले सकते हैं, वो भी बताएंगे कैसे. Listen, see, assume a weak base, BOH. It dissociates in aqueous solution. It dissociates in aqueous solution and gives it the following equilibrium and gives the following equilibrium. So BOH gives rise to aqueous, BOH gives rise to B plus aqueous plus OH minus aqueous. Right? BOH aqueous gives rise to B plus aqueous plus OH minus aqueous. If you go through initial moles, C moles per liter, initial concentration C moles per liter 0, 0. Now, at equilibrium, its concentration C alpha and it's a C alpha, then this one C into 1 minus alpha. Okay. Therefore, dissociation constant of a base, better to say a weak base, of a weak base. So before also said, already we written weak base in the top, right? So dissociation constant of weak base Kb is equal to C alpha into C alpha by C into 1 minus alpha. C get cancelled. Kb is equal to C alpha square by 1 minus alpha. Right? And one more point. For a weak base, alpha is very, very less when compared to 1. Therefore, alpha is neglected in denominator. Alpha is neglected in denominator. Okay. Therefore, Kb is equal to C alpha square. Alpha square is equal to Kb by C. Alpha equal to root Kb by C. Again, since OH minus ion concentration is equal to C alpha. Therefore, OH minus ion concentration is equal to root Kb into C. OH minus ion concentration will be root Kb into C. Therefore, POH is equal to minus log OH minus ion concentration. So, therefore, POH is equal to minus log root Kb into C. Okay. So, let me evaluate this. Okay. Now, POH is equal to half into log Kb minus half log C. So POH is equal to separate the half minus log Kb minus log C. Since minus log Kb is always equal to pKb, therefore POH is equal to half into pKb minus log C. Okay. And sir, if you want to calculate pH, then what we do? So you know that at any temperature, sum of pH and POH should be equal to pKw. At 25 degrees centigrade, pH plus POH should be equal to 14. Therefore, pH is equal to 14 minus POH. So finally, pH is equal to 14 minus half into pKb minus log C. So this is the way to calculate the pH of a weak base as per Arrhenius theory. And again the points are same. Okay. I'll write again. Okay. Listen carefully, all of you. Okay. Higher the value of Kb, more will be strength of the base. Higher the value of Kb, more will be the strength of the base. Next, less will be the value of pKb, more will be the strength of base. More will be the strength of the base. Okay? Understand? Less will be the value of pKb, more will be the strength of the base. Again, less will be the pOH, more will be the strength of the base. I written pOH. Sir, pH limits, more will be the pH of base, more will be the basic strength. So we written more is the pH of base, more will be the strength of the base. Okay. So this is about Arrhenius theory. Now let me go through limitations of this Arrhenius theory. What are the limitations we have to follow in Arrhenius theory? So listen carefully. See, limitations. See, it fails to explain nature of acids and bases in non-aqueous state. Okay. So it fails to explain nature of acids and bases in non-aqueous state. For example, dry HCl is an acid. We call it as an acid, but it doesn't dissociate it to H plus, or it doesn't give H plus ion. So the best example, that one example, dry HCl is an acid, but Arrhenius theory fails to explain nature of acids and bases in non-aqueous state. Next, second one, it fails to explain acidic nature of a certain salts like BCl3, BF3 and CuSO4, etc. Okay. Fails to explain basic nature of certain compounds like LH3, pH3, etc. Okay. And one more important point, fails to explain why H plus exists as H3O plus, that is hydronium ion, in aqueous state. Hydronium ion in aqueous state. So fails to explain why H plus exists as H3O plus, hydronium ion in aqueous state. So that's it. It's about limitations of this Arrhenius theory. Okay. So to overcome these limitations, the next theory was introduced by Lowry and Bronsted. So that's what we call the Lowry-Bronsted theory. Okay. And that Lowry-Bronsted theory will be explained in next class. Okay. First, let me go through a few points related to this Arrhenius theory. through few points related to this Arrhenius theory. Okay, so what else? See, if you want to go for relative strength of two acids, see, relative strength of two acids can be given like this. Relative strength of two acids can be compared by the ratio of their extent of dissociation. By the ratio of their extent of dissociation. Understand? A relative strength of two acids can be compared by the ratio of their extent of dissociation. Okay. So alpha 1 by alpha 2 is equal to root over Ka1 by C1 by root over Ka2 by C. If they have same concentration, if the two acids have same concentration, that means C1 equal to C, then alpha 1 by alpha 2 is equal to root over Ka1 by Ka2. Okay. Next, another point. If two acids are same kind with different concentrations, right? If two acids are same with different concentrations, मतलब क्या होगा? Ka1 is equal to Ka2, therefore Ka1 equal to Ka2. Then alpha 1 by alpha 2 is equal to root over C2 by C1. Okay. So like that you can compare relative strength of two acids and two bases like this. Okay. So Arrhenius theory is completed. So definitely in the next class I used to explain Bronsted and Lowry theory and Lewis theory. See, these theories are very important to understand the strength. Usually in NEET and JEE, the questions are which of the following is strong acid and which of the following is strong base. Okay, what is the ratio of their relative strength? What is the ratio of their dissociation constant by giving extent of dissociation like that. So for that purpose this topic is very important, and if you know the basics properly you can get the remaining questions quite easily. Okay, so until then, bye bye. So if you like this video, please like, share, subscribe and give valuable comments also. Yeah, obviously the gap, मतलब लास्ट वीडियो से अभी वीडियो में गैप ज़्यादा हो गया, सो अभी मैं फ्रीक्वेंटली वीडियोस बना के आपको पोस्ट करेंगे. थैंक यू सो मच.